All right, good morning. My name is Greg Waverly with CTC and Associates. I'm the Clear Roads Administrator. We're here for the final project webinar for the project entitled, for Clear Roads Project 20-06, entitled Salt Shed Design Template. This research effort was led by Wilf Nixon of Wilf Nixon and Associates. And before we turn it over to Wilf, I'm going to just remind everybody that this webinar is being recorded and it'll be posted within the week. And just that way that you and your colleagues can view it at your own convenience. We also ask that unless you're speaking, please keep your microphones muted and stay off camera during the presentation. If you have any questions or comments during the presentation, please enter them into the chat box and we'll address them at the end. So I think that's it. I'm going to turn it over to you, Will.
Okay, thank you very much, Greg. Thank you all for being here today. As Greg mentioned, this is the Salt Shed Design Templates project, our final webinar. And the outline, what I would like to go through today with you all is introduction and context, then the literature review and survey results, the key findings, the design tools, our recommendations and conclusions, and then, as Greg indicated, Q&A, so we can address any questions or concerns that have arisen as a result of the presentation. So the purpose of the project was, in essence, to create design tools that would allow us to efficiently and effectively design salt storage facilities. 5 tasks were identified and these have been completed. The literature review, a nationwide survey of practices, analysis of the collected information, the development of the design tools, and finally the submission of final deliverables, of which this webinar is part. In terms of the literature review, it became very rapidly apparent there were 3 main areas of literature. The largest was associated with minimizing environmental impacts, which I don't think is particularly surprising. Much of the concern over salt shed design and construction has come from concerns over environmental impacts that have arisen due to storage that was not as good as it needed to be. There is another part of the literature that deals with the optimal location of a salt storage facility within a road network. That would be something that you might be considering if you, for example, had a new area you were taking over and you could put your storage facility anywhere within that area. It might also be a concern or of interest if you are considering factors associated with satellite salt storage facilities so that your trucks could refill without having to come back to a central location as appropriate, allowing them more time on the road and therefore less time deadheading and things like that. And finally, there were a number of studies related to design of these structures and the insights gained from them and the experience that various people had when they constructed their own facilities. We'd had an original goal of gaining insight from storage of other materials, other granular materials, but that didn't unfortunately yield any useful information. The key reason being most of the other, or at least as far as I could tell, all of the other granular materials that are stored are not water soluble, things, for example, like gravel. So the need for cover doesn't exist. Nonetheless, we gained from our total literature review several useful findings. And in terms of the environmental considerations, very clear that the number one thing you can do is do your salt storage on an impermeable surface. If you don't, if it's just stored on earth or soil, then salt will leach into that soil and will thereby get into the groundwater and possibly into nearby rivers, lakes, and streams, and that's obviously not a desirable outcome. You have to consider issues of drainage, and it's a two-way consideration. The first is to ensure that when it rains on site, the drainage of that rainwater into your storage facility must be minimized. This can be done to some degree with sloping, and in a number of structures has been done with, in essence, creating a little moat around the facility. The nice thing about those moats is they collect any drainage out of the facility. If any moisture should happen to get into the facility, and that drainage out of the facility needs to be collected and appropriately disposed of. A number of agencies reported using that drainage out of the facility as basically feedstock for their brine making. I would note parenthetically that was also possible with truck washing. Again, a number of agencies have used the runoff from their truck washing after separating out detergents and oils and the like as a feedstock for brine making. Third major finding here was that where you put your facility can help to reduce potential impacts substantially. And there are a number of agencies that are required to place them a minimum distance away from any water sources, any rivers, lakes, or streams. 200 or 300 feet is a number that was quoted or that was mentioned in several different resources. So on the environmental side, there are concerns, they can be addressed, and there is pretty good guidance as to how to address them. In terms of the structural types and trade-offs, there are three basic types. You can have domes, or in some cases, people use elongated domes. An elongated dome is, in essence, a variation of a rectangular shed-type structure. The rectangular shed-type structures have regular roofing. An alternative to those is a rectangular fabric-covered structure. As you might expect, each has benefits and drawbacks, and part of those are the balance between construction costs and maintenance costs. A general notion from the various literature was that if you can, and if your agency allows you to do so, life cycle cost analysis might be the best approach if that is an option for you to take. Of the structural types, and let's take a look at them here. On the top right, we have a basic dome structure. In this case, there are no vertical walls in that dome structure. It's a very simple structure. You can notice the doorway is significant in terms of being fairly obvious, which is good, I suppose, but also is designed to provide protection against the elements when you're loading trucks or going through the loading process. One comment that came out with regard to dome structures was to make sure, and I guess this applies in all structures, that your doors are placed so as to be as sheltered as possible from prevailing winds. On the bottom right, we see an elongated dome structure. This one does have vertical walls before you get into the dome roofing. Obviously, this is a structure that is designed to store a lot of salt. Top left is a typical rectangular building. Again, you'll notice very high doorways, entry in there, and also, and this is common with many of these rectangular shed-type structures, there's quite a lot of storage on the side of the structure that is not for salt, but is for other things in and around a winter operations facility that need to be protected from the weather somewhat. And then down in the bottom left is a rectangular fabric roof covered structure. In fact, two of them. This is a shared salt facility for various of the municipalities in the Des Moines area. They pulled together to be able to get a large volume of salt storage that would allow them to buy salt in years when there was a low price and not need to buy it in years when there was a high price. But the basics of the structure are there. You can see in this case, the wall is ecology blocks. There is a hooped roof with fabric over it and fabric on the doors and the ends as well. In terms of pros and cons of these various structures, you can see fabric covered is going to be a low initial cost for a given area or volume of storage. But as a con on that regard, there will be a higher lifetime maintenance for these structures. For the roofs in particular, the material, that fabric, appears to need to be replaced from time to time, which is no big surprise. And also, although this isn't necessarily an area where we have equations to guide us, it's generally considered that such structures have a lower aesthetic appeal. The rectangular shed type structure, definitely flexibility in terms of usage. I mentioned that storage along the side of the buildings. Others use these sorts of structures to do things like, for example, load trucks inside undercover, so on and so forth. It should be noted this is not the most efficient storage footprint, but if you are in a situation where your salt storage facility has to serve a number of needs above and beyond simply salt storage, it may be a suitable solution. And then finally, the dome structure, if all you are concerned about is your optimal storage solution, storing as much salt on as small a footprint as possible, then this is the one for you. It doesn't have flexibility of usage. It's pretty clearly just for salt. Some would consider it has a higher aesthetic appeal, and it certainly appears to have the highest cost range. Okay, let's see. When it comes to cost, based on the literature, and bear in mind the literature is, of course, over a number of years, so it's not a snapshot of how things are today, nor is it a snapshot of how things are across the country, but the data from the literature review suggests that if you take your fabric covered structure as your basis on a per square foot basis, then the rectangular shed type is going to be between 20 and 50% more expensive, and the dome type would be between 60 and 140% more expensive. There is clearly a wide range here, and that range reflects the wide variability of pricing across the country. It's not clear that all of these structure types are necessarily equally available all the way across the country. So that too is a factor to consider. We do not have useful data on whether or not they are widely available. So that is a concern when it comes to comparing the cost on a square foot basis. From the literature, we gained a number of operational insights. Definitely the most important is the benefits associated with loading your salt storage facility with a conveyor system. It is much more efficient. than using a front-end loader or a similar mechanical means. And the literature suggests that with a conveyor, you might be able to make use of as much as 90% of the available volume inside the structure, whereas mechanical pushers of one sort or another allow only about 60%. So if you are constrained on size and you want to maximize the volume of salt you can store in that size, a conveyor system is definitely worth considering. It's also, there is a safety benefit. There are multiple reports of front-end loaders coming to grief inside salt storage structures when they tried to push that last little bit of salt up to the top of the pile and ended up flipping over backwards. There's also some interest in loading trucks inside. It's inherently, well, it will reduce lost salt. When you load a truck, you do lose some salt. Again, the literature suggests you lose about 0.3% of your salt if you load outside, but only 0.06% if you load inside. To put some numbers on that, what that would mean if you use 10,000 tons of salt from a facility in a year, then by loading inside, you would save 24 tons that would otherwise be wasted if you loaded outside. So it's not a huge benefit. There may be other benefits in terms of improved lighting, and depending on the setup inside, you may be able to significantly improve safety for the whole loading process. But in terms solely of reducing salt wastage, it's not huge. It exists, but it's not huge. The survey, we sent that out to about 40 agencies across the country. Most were DOTs, state level agencies. We did take a number of city or county level agencies that we knew had recently put in place new storage facilities. We ended up getting 16 responses that covered 21 different storage facility designs. Some of the agencies obviously use more than one storage design or facility type in their storage solutions. You would expect to see significant variations, and we did, in storage size and design life. The design life, most were in the range of 25 to 50 years. A few were 20 years. What we did find was some very useful information on maintenance practices, the best sort of coating to put on various bits of your structure, and this sort of idea of what the maintenance costs could be and how to minimize those while maintaining the lifetime of the facilities. About half of the agencies that we surveyed use their facilities for things other than just storing salt. The most common was brine making, but there was also truck loading inside and truck washing. Finally, from the survey, most agencies were happy with their facilities, although there were some concerns related to site-specific constraints, the major one being we only had so much room, and therefore we couldn't put as large a facility on site as we really wanted and or needed. Those are not surprising results in a way, but the good news is most agencies were happy with their facilities. Here's that data on the design life. As you can see, a few were as low as 20, but majority were in the range of 25 to 50 years for their design life expectancy. We use that information to develop the two design tools that are the products of this project. The first was a structural sizing spreadsheet, which works in two ways. If you have a given storage amount, you need to store, say, 20,000 tons of salt, then it'll give you size for a variety of building options, whether you are going with a rectangular or a circular storage facility. It'll tell you how big that needs to be, either what its diameter is or its length and width footprint. Conversely, there are some situations where you only have a certain amount of space, and it'll tell you how much salt you can get inside that space. We'll dig into this in a minute here. The second tool we developed was a design process checklist. It lays out the steps that you need to consider as you go through the design process. The goal behind this was to ensure that you don't miss out anything that is a critical step along the way that will come back and bite you later on, which is something we would like to avoid insofar as possible. So that's the overview of the design tools. Getting into the structural sizing spreadsheet tool, there are, and it's based upon two primary assumptions, need to be upfront about these. The angle of repose of a salt pile is 32 degrees. That is, if the salt is reasonably dry and does not create a crust, then it will create a pile that has a maximum angle of 32 degrees. And secondly, the density of granular salt is approximately 80 pounds per cubic foot. There will, depending on the grain size, be some difference in that. But if you take a typical grain size distribution, which is what is normally specified in the bid documents, then you end up with a density of about 80 pounds per cubic foot. We set up in the spreadsheet with 3 tabs: storage in a conical pile, storage in a circular building with walls, which that little drawing shows there, and then storage in a rectangular building. And you can go through on the tabs and figure these things out. The guide takes you through all the equations in case you want to read those sorts of things, and identifies, and this is the most important, the guide aspect of the guide. It takes you through step by step the process that a user has to follow to get useful sizing information. And at the end of that process, you're going to get size for a given storage amount needed or storage available in a given footprint. You see the little cut there from the one of the spreadsheet tabs. This is for a conical solution, and if you want to store 12,000 tons of salt in a conical pile, it's going to have a diameter of about 155 feet and a height of about 48 feet. And it'll take you through that for whatever your storage needs are in whatever footprint you wish to consider, whether it's rectangular, circular, or what. We do, in that spreadsheet tool, get into this, are we using a conveyor or a traditional salt storage method? It allows you to do a very rapid comparison. You can, in essence, select one or the other, and it'll show you very clearly what difference in storage you're going to see if you use a conveyor system as opposed to traditional mechanical methods, because of that 90% utilization versus about 60% utilization. We thought that was an important comparison to make available to the user. I know that there are costs associated with a conveyor system, but being able to increase your storage volume by as much as a conveyor system allows has significant financial benefits as well. So the checklist approach, here we're wanting to make sure that you've had a chance in the process to dot your I's and cross your T's. We broke it down into 5 topic areas: sizing and footprint, site selection, environmental, structure type, and the ubiquitous general and other. And in each of these areas, there are a number of decision points identified. Now, the goal here is not that you're going to go through this in a linear manner. The expectation is you will go through and do a first cut at the sizing and footprint and so on and so forth. And then your site selection information might say, oh, we only have this big a footprint. Or your general other considerations might be saying, oh, we only have this big a budget. That's going to constrain the other things that we can do. So the point is to just make sure as you go through that you can check that you've covered all the areas that you need to cover. So here's the sort of things that we do. This is one of the topic areas. This is for sizing and footprint of the facility. And the goal here is determine how much salt the facility must store and what size of facility will be needed. So first thing you need to do, is this the primary storage facility for your location, or is it satellite storage? That's going to give you a sense of how much salt you need. Decision after that is, okay, once I know that, what are my future salt storage needs? Incorporating, for example, expected growth in lane miles. Also incorporating, if needed, and we'll touch on this in a minute, any concerns about climate change impacts on how much salt you might need. And then you go through and you actually run the calculations in the spreadsheet for various structural shapes, and you come up with some output on that basis. You have an initial size. Now, future things may change this. The recommendation that is in the literature suggests that you should have 100% of your expected annual salt usage that you calculate using 5 years of salt usage, and you average out those 5 years. You may not have enough space to do that, but you can begin with an optimal storage volume and then adjust that as needed to take other factors into account. So, and you go through these similar sorts of decisions in each of these areas as laid out in that document. So again, we have the goal for the section, the decision points, and the desired outcome of the section is given. And the expectation here is that an iterative approach is going to be the most fruitful way of doing this. So we did put together, at the suggestion of the panel, an appendix that dealt with how you might consider climate change impacts on your storage needs. We've called this an attempt because there is significant uncertainty on how this might happen. The approach is basically to look at the winter severity index for that location and examine how it's changed over past years, use that change to project how it might change going forward. You need to understand 2 major assumptions about this. The first is that salt needs are directly related to winter severity. That is one of the purposes of some of the winter severity index tools out of there, but not necessarily all of them. So you would need to check and make sure that your winter severity index that you use is appropriate if that is what we are trying to do with it. The second assumption, and this is the one that is most concerning, is that whatever trends in winter severity have been happening will continue to happen. And the concern there is similar to the concern about, I guess, investment in anything that past results are not a guarantee of future results. We don't have a great deal of certainty about either assumption, but we have provided a method whereby if you are required to do so, you can include climate change into your analysis of salt storage needs. So we can discuss that further in questions if that would be an area that people might have an interest in considering. So to conclude and get to your questions, this has been an investigation of how salt storage facilities are currently designed and used, with the identification of key factors that agencies would consider when designing such facilities. There is a robust spreadsheet tool that allows you to do size and storage calculations and comparisons, and a comprehensive checklist that serves to guide you through the design process to ensure that, if you will, all the I's are dotted and all the T's are crossed. And with that, I'm going to stop sharing and do my best to take any questions that might have come up or be in the chat. Greg?
All right, thanks, Wilf. Looks like Clay Adams has a question.
Well, I've got some
Go ahead.
questions and comments, if I may. Can you go over the scope of this project? Because I was expecting a little bit more on the actual design of salt storage facilities, as far as concrete walls and reinforcement needed. So I may have missed what the scope of this project was.
Yeah, we can, in terms of the scope.
I don't know, James may have a better sense of what his expectations were for this project since he was the champion for it.
It was intended to create design tools to allow design for salt storage facilities. And one of the issues, and yes, it was intended to have what we might call scalable designs, but you rapidly get into a situation where the difference between storing 2,000 tons of salt and 20,000 tons of salt, it's not particularly scalable in terms of, the wall thickness should be the amount of salt you store multiplied by this factor. That just did not work out.
Okay. I'm not aware of, you talk about conveyor use being a big difference, and I'm not aware of conveyor loading rectangular buildings being an advantage. I see it in loading the round buildings. That's the only place we've ever attempted to use a conveyor is for a round building. So I question the advantage of using a conveyor in a rectangular building. I wondered about your comment about people washing trucks in a salt storage building. That kind of caught me by surprise, why you would wash trucks in a salt storage facility. Were there specific examples of that?
There were, I forget now which state it was in, but there was a state. Now, this is where the salt storage facility was much larger than the area in which they stored salt. So possibly in that case, and I don't have the numbers directly in front of me, but maybe only about a third of the square footage was set aside for storing salt. There was another portion set aside for brine making, another portion set aside for loading, and a final segment set aside for truck washing. So it was much more than simply salt storage in that regard.
Okay. On your round design information, from my exposure, there's only a couple of companies that build the round structures, and they already have the data. I mean, if you called them up and said, I need to store 1,200 tons of salt, they would tell you, well, with a 4-foot wall, it needs to be this big around. If a 6-foot wall, it needs to be this big around. So I'm not sure how your spreadsheet works with those. I'm not sure of anybody that's independently building round buildings.
Well, no, that's an excellent point. We double checked the results from our spreadsheet with other information that was published and was out there, and checked it against a couple of designs that had recently been constructed. So we know where we are, but you're quite right. Yes, if you go ahead and call up one of those companies, I am quite certain they have those tools. Yes.
Okay, I just, I'm not sure that you addressed the sidewall height when you talk about, well, I've got this big a footprint that I can store salt in. And I mean, you can double the amount of salt you can store if you double the height of your sidewalls. So I'm not sure, does your spreadsheet take that into consideration?
Yes, it does. It allows you to examine different sidewall heights and to see how much you can store with those. Yes. I'm sorry, I misunderstood your question.
Okay. All right. That's all I had. I guess my expectations of this was, I was hoping we would come up with some scalable design drawings, but I understand that was ended up being more than what was possible with building codes and loading. So those are all the comments I had. Thank you.
Thanks.
Okay, got Patty Caswell with her hand up.
Hi, Wolf.
Hi, Patty.
I just had a couple of questions. I think I understand what you're talking about with conveyor loading, but that's messy. Isn't that messy? I mean, I just quickly Googled like loading a salt shed with a conveyor system, and there's salt all over the place on the outside of the shed, right? It's a mess. So
It can
I
be,
guess
yes.
I'm curious too. The other thing I'm curious about is, well, this kind of goes hand in hand with what your triage, I would call it, decision making, right, for how the size of the shed. I'm assuming, I haven't seen the guide yet. I haven't looked at it if it's available yet, but I'm presuming that if you are planning on loading inside, that's included in like the amount of space that takes up, that needs to be considered when you build, right? How much you need to set aside for that. And then my question about, so you can answer that in a second, but I was wondering about loading inside the shed using a conveyor into the truck, from the pile to the truck.
Okay, to the best of my, yeah, no one does that here. They do have something that might be similar to that over in Europe, where you have a sort of silo, an inverted grain silo, if you will.
Oh, okay.
You put the salt in the top and you drive the truck underneath. We tried to find examples of that here, and we're told that people didn't do that. One of the reasons being that for structural reasons, those tend to be metal and therefore tend to corrode. And making it out of stainless might be kind of expensive. But I do see the point of, yes, if you're going to have a fully flexible conveyor system, then you could definitely turn that around and use it to load the trucks if it were appropriately designed. My thinking on the conveyor system was either there are a number of relatively new facilities, that elongated conical structure that was in one of the photographs is one that uses a conveyor system to load all the way along. So they can set it to different heights, but there are also agencies that use mobile conveyor systems that they can simply tow from facility to facility and use it in those facilities to do their loading in that regard.
To load the facility or load the truck?
Load the facility. And I
Yeah.
see
Just seems messy.
it, any of these things can be messy. Yeah.
Yeah.
In
Well, I
terms
mean,
of,
anytime you have salt outside of the shed is not where it's supposed to be, right? It's
right,
supposed to be inside.
right. Yes,
Okay.
absolutely. Yeah. Yeah.
Thanks.
And a couple of comments there in the chat. Yeah.
From Clay, it says we used to have some of those. The salt was blown into the top and was dumped into the truck with a clamshell gate at the bottom of the bin. They all rusted out. And then Ty asked, conveyor or auger?
Yeah.
Well, I think
Again,
that's just a comment on that. I don't know if we're talking about, mobile conveyors or, stationary auger systems. There's two different. So I wasn't sure, Patty, to her question.
I don't know what I'm talking about. I just know I've heard from our folks that don't like loading their trucks inside a shed because it takes up too much space and they can't store enough salt in there. They kind of undersized their facilities and they want to use a conveyor system to load the truck outside. That's what my understanding was. And I guess my question on that would be, would that be a mess or would that be a clean way to do it and the salt doesn't, maybe that's a cleaner, tidier, I should say, way to do it than the loader, but
Yeah.
we require loading inside. So I was just kind of curious about the conveyor for maximizing storage space.
Yeah. Patty, that's a very interesting point. I was somewhat surprised by how little loss there was associated with loading outside versus loading inside. That if you loaded outside and you loaded 10,000 tons over a winter, you might lose 30 tons. If you loaded inside, you might only lose 6. Now, of course, 6 isn't good, nor is 30, but it wasn't the sort of difference I expected.
Yeah, and I guess my concern isn't the loss of salt. It's more the salt is outside of the shed. So now you have to clean it up or it's getting in the water and it's running, that's the whole purpose of salt being in a storage facility so that it doesn't go outside. And I guess the question
absolutely.
even if you're conveying it from the shed, you still have to scoop it into a hopper that's loading a conveyor. I mean, I don't know how much space you're actually saving if you're using a conveyor to load a truck from the shed to the truck. I just was
Right.
It doesn't seem like it would save that much space to me.
Right. Yeah, and thank you for that example, that photo from
yeah, that looks like it's mostly undercover and they load the hopper up. Yeah.
Yeah. So, and that's from Pat, even though he says he's Vincent, right, Pat?
Correct. For us here in Minnesota, in our larger salt sheds, they do use the conveyor to fill the trucks. Our newest design, in order to keep things out of the weather, we try to keep at least a 20 to 25 foot area where there is no salt in the design so that we can load trucks under cover. And allow for any type of rain or something to come into the building without it affecting the salt pile. But we do use both, where we just use a front end loader or a conveyor system to bring the salt into the building.
And you use a conveyor to load your trucks inside
No.
or other? Oh,
No, inside, underneath the cover of the building, we have usually it's anywhere from 20 to 25 feet where a truck can back in, and then the front end loader will load up the
Okay.
trucks. We don't use a conveyor system to
Gotcha.
load
It's
up
only
any truck.
you only need 20 feet, 20, 25 feet. That's pretty good. Okay.
Yeah, it's just enough so that they can maintain up to where the front of the salt pile would be at the beginning of the season.
Yeah.
As they're using it, you are getting further back into the building.
Yeah. Yeah. Obviously. Yeah. Okay. Thank you.
Thank you, Patty.
Okay. Does anybody else have a question for Will? Matthew?
Yeah, sorry if you already covered this, but yeah, if you have to load under cover, would that be additional area we'd have to factor in as part of this when looking at the size of a building?
Yes, it would. It's not something the spreadsheet only considers the salt storage, but in the checklist, we do talk about the need for additional space if you are going to do loading inside. But we will, I will make sure that we have that sufficiently called out so that people can do that. If you're doing that, if you're loading inside, I'm not sure that a conical structure is going to be optimal for you in that regard, and we'll include something along those lines as well.
Okay. Thank you.
Thank you.
Carl Fetters from Michigan added in the chat, Michigan DOT requires indoor loading on new facilities. No conveyor use. We use auger systems to load brine makers. We have ideas and pricing to use augers to load inside and dispense into trucks like a grain auger into a truck outside.
Yep. It's useful stuff. Thank you.
Any more questions?
What does an auger system look like? I guess I have a question. What is an auger? I don't know what does that look like? I can't think of what that looks like. I mean, I know what an auger is. It looks like a large screw spinning, right?
Right. Yeah, it's an Archimedes screw, if you like. But yes, Jeremy's got it. It's a big corkscrew. Yeah.
Yeah, but how? Okay. Interesting. Okay.
And these don't necessarily go terribly quickly, but it doesn't have to be fully enclosed. It can be partially open along its length, and there we go. Ty's got an example. So yeah, that one is fully enclosed. So that's awesome.
Huh. Interesting. Okay. Interesting.
This Clay, I'd also share that they make augers like this that are they're round, but they have a belt in them instead of an auger. They're cheaper than the big square Kimco conveyors, but it's round, it's got a conveyor belt in it, so you end up with less salt being ground up.
Ah, I see. Okay. That makes sense. Sounds like that would be bad.
Well, you'll certainly get more mess if you get a lot of salt being ground up.
Yeah, and you're kind of losing your, what am I trying to say here? Different sizing, right?
Yeah, your distribution, your size distribution, you're
Yeah.
making it finer. Um,
Anybody else? Okay. Well, thank you everyone for joining in. Will, thank you for your time today. I will have this posted within the week, and I'll notify the Technical Advisory Committee when it is up. So have a good lunch, have a good rest of your day, and we'll talk to you all very soon.
Thank you all.
Thanks, Greg. Thanks, Will. Thanks all.
Thanks.
Thanks.